All right, let's pick up with example 3. I want to relate back to that 30, 60, 90 triangle. And it looks like my example here is a little bit like what I had a second ago, but let's go ahead and compare these two. We are going to find the value of x using the definition of tangent. So that's that opposite over adjacent. Then we're going to find it using the 30, 60, 90 theorem, and we'll compare. So let's use the tangent idea. So with tangent, from 30, I've got my opposite leg, O, my adjacent leg, x. And so if this helps you to have tangent of theta, or tangent of an angle, is O over A, opposite over adjacent. So tangent of, plug in your degree measure, equals, opposite is 5 times the square root of 3, adjacent is x. All right, I'm going to go ahead and just cross multiply and solve. So when I multiply, I'll multiply on this side with the x. So it'll be x times the tangent of 30 is equal to, this diagonal would just be 5 square root of 3. Now, remember, this is simply a number. This is a number times x. So I'm going to come through here and divide off the number. So I'm going to divide both sides by the tangent of 30. If this said 5x over here, you would divide by 5. Okay, so these guys are going to cancel. So x is going to be, and then here's where I'm going to grab my calculator. All right, so I have 5 times the square root of 3. Now, do you see how that opened up a parenthesis before I hit my 3? I need to close my parenthesis. Then I'm going to divide by the tangent of 30. I get exactly 15 on this one. Okay. All right, let's do the 30, 60, 90 rules. So I've got short leg, long leg, hypotenuse. So to go from short to long, which is what I want, I can simply multiply by square root of 3. So if I take the short leg and I multiply by square root of 3, square root of 3 times square root of 3 is just 3, and 5 times 3 is 15. So look at how I get the same thing using either method. So that again reinforces that all triangles are similar, and that's how the tangent of 30 has an actual number that goes with it. It's just the decimal of that particular ratio. Okay, let's continue on. Number 4. Let's skip B. We're not going to do cotangents, like I said, so let's skip that. So let's go back to example 4, where we go back to just writing the tangent of angle A. So I'm not solving for x. I'm simply writing, back to that very first example, I'm simply writing the ratio of opposite over adjacent. All right, so tangent of A. So from A, let me start out my answer. The tangent of A equals, opposite of A is 40, adjacent leg to A is 42. 58 has nothing to do with tangent. We also need tangent of angle B. So tangent of B is equal to, so from B, now my opposite leg is 42, my adjacent leg is 40. And that's all we're writing if we know all three sides. I'm simply writing that particular ratio. Okay, let's solve. So last two on solving, I am going to use a trigonometric ratio here because I only know one side length and I have an acute angle. So from 25, of course here's hypotenuse, so this is my opposite leg, this is my adjacent leg. So we're going to set up that equation. Tangent of a degree measure equals opposite over adjacent. Tangent of 25 degrees equals 32 over x. So I can create a proportion. I can now cross multiply. So I'm going to have x times tangent of 25 equals 32. Now remember, tangent of 25 is simply a number. So I'm going to divide both sides by that number. Tangents are canceling. round to the nearest tenth when necessary. So I'm going to do 32 divided by tangent of 25. So I get about 68.6. Approximately 68.6. Okay. Try the last one. Try letter B. Go ahead and set your tangent up and solve for x. Okay, from 41, here's your h. Opposite is x, adjacent is 20. So tangent of 41 degrees equals opposite over adjacent, x over 20. Cross multiply. So 1 times x is going to be x. 20 times tangent of 41. And then looks like I just need to multiply over here. So 20 times the tangent of 41. So approximately 17.4. Okay, and so those are my side lengths. Okay, well that wraps up tangent. If you have any questions, let me know. Our next lesson we'll talk about sine and cosine, which represent these other two trigonometric functions.